In 7.1 and 7.2, we have learned the scale diagram. A scale diagram can be a reduction or an enlargement of the original diagram. Based on what we have learned in 7.1 and 7.2, we have already realized that the scale diagram is similar to the original diagram. What's the meaning of similar? Today we will look at 7.3, similar polygons. Before we introduce the concept of similar, we will look at a symbol. So this symbol is a similar symbol. This one looks like a sideways S. So this one means similar. When one polygon is an enlargement or a reduction of another polygon, we see these two polygons are similar. Similar polygons must have the same shapes, but not necessarily the same size. The matching angles in both of these two similar polygons are called corresponding angles. The matching sides in these two similar polygons are corresponding sides. If two polygons are similar to each other, these two polygons must have these two properties. The first one is their corresponding angles must be equal, and their corresponding sides are proportional. The meaning of proportional means the ratios of their corresponding sides must be equal as well. So right now, let's look at two similar quadrilaterals. So quadrilateral ABCD is similar to quadrilateral PQRS. So we can use the similar symbol instead of the words to describe the relationship between these quadrilaterals. So let's look at how can we justify why these two quadrilaterals are similar to each other. Look at the symbols on angles. Both of angle A and angle P have one arc as the representation to show that these two angles are the same. So we will know angle A corresponds to angle P, and they are equal. The same idea as angle B and angle Q. Based on this same symbol, we can know angle B corresponds to angle Q, and they are equal as well. And these two symbols represent angle R equals angle C. So angle R corresponds to angle C, and they are equal. This small square symbol represents angle S equals angle D. Angle S corresponds to angle D, and these two angles are equal as well. So after we identified all those corresponding angles are equal, right now we need to look at if the corresponding sides are proportional. The corresponding sides are proportional means I have the ratios of the corresponding sides are equal. So let's look at the first ratio, which is the ratio of AB to PQ. And we found that AB and PQ, they are two corresponding sides in both of these two quadrilaterals. AB is 1.5. PQ is 2.1. If you want to put out centimeters, that would be great. Okay, but we all know this one is a ratio. That means these two quantities have the same unit. I can cancel this unit. So 1.5 to 2.1, I can reduce this fraction to the lowest term, 5 to 7. This is like the scale factor. If you want to change this ratio to a decimal, that's also okay. So this decimal is approximately equal to 0.714. Let's look at the second pair of the corresponding sides. BC corresponds QR. BC is 3.0 centimeters, and QR is 4.2 centimeters. Cancel the centimeters and reduce the fraction to the lowest term. I find that this one also can be reduced to 5/7. If you change this one to decimal, it's also equal to 0.714. So these two ratios are proportional. Let's look at the third pair of corresponding sides. CD corresponds to RS. CD is 3.0 centimeters. RS is 4.2 centimeters. If I reduce the fraction to the lowest term, I find that this simplest fraction is also 5/7. Of course, if you want to change this one to the decimal must be 0.714. dA over SP. dA and SP, they are two corresponding sides. dA is 2.0. SP is 2.8. If I reduce the fraction to the lowest term, this one is also 5/7. So right now I found that 4 ratios are really equal. So we can draw a conclusion that the corresponding sides are proportional. Based on these two pieces of information, their corresponding angles are equal. Their corresponding sides are proportional. I can draw a final conclusion that this quadrilateral ABCD is similar to this quadrilateral PQRS. So when you want to justify two polygons are similar to each other, you have to justify through the corresponding angles as well as the corresponding sides. Let's look at example 1. Identifying similar polygons. Here you will see I have 3 rectangles. Are these 3 rectangles similar to each other? So let's identify pairs of similar rectangles and justify your answer using the numerical values. Corresponding angles in those 3 rectangles are equal because all angles of a rectangle are 90 degrees. So all the interior angles are 90 degrees. So we will see their corresponding angles are the same. Let's determine if corresponding sides are proportional. Compare the corresponding sides for each rectangle. Let's look at the first pair. If we want to look at the rectangle ABCD and the rectangle EFGH, if we want to determine if they are similar to each other, we know their corresponding angles are the same. We need to look at if their corresponding sides are proportional. So we will see side AB corresponds to side EF. So I use 8.5 centimeters and 8.4 centimeters to make a ratio. 8.5 to 8.4. I change this ratio to a decimal. This decimal is approximately equal to 1.011. BC is corresponding FG. So I will make these two side lengths in one ratio. So 2.5 to 2.4. If I change this ratio to a decimal, it's around 1.0416. I find these two ratios are not equal. Although their corresponding angles are equal, their corresponding sides are not proportional, so they are not similar rectangles. Now let's look at a rectangle ABCD and the JKMN. We can see their corresponding angles are the same. So we want to compare their sides. So AB is the length, corresponds JK, which is also the length. So it's 8.5 to 5.25. We can change this ratio to a decimal. It's around 1.619. Let's look at the ratio of the other corresponding sides. BC corresponds KM. So BC is 2.5. KM is 1.5. I can change this one to a decimal. So this ratio is around 1.666. Okay, we will find although these two approximate values are very, very close to each other, however, the ratios are still not equal. So that means their corresponding sides are not proportional. So these two rectangles are not similar rectangles. Let's compare rectangle EFGH to JKMN. So let's look at the first pair of the corresponding sides, EFJK. EF is 8.4 centimeters, JK is 5.25 centimeters. If I convert this fraction to the decimal, it's 1.6 exactly. Let's look at both of these two widths. So FG corresponds KM. FG is 2.4 centimeters. KM is 1.5 centimeters. Cancel the centimeters. This fraction can be reduced to 1.6, such a decimal as well. So in these two rectangles, I can find their corresponding sides are proportional as well. So these two rectangles are similar to each other. The final conclusion is rectangles EFGH and JKMN are similar rectangles. From this example, we realized that sometimes even if we have the corresponding angles are the same, however, if they don't have their corresponding sides proportional, they are still not similar polygons. From this example, we can realize one thing. For two polygons, even though they have their corresponding angles are equal, however, if their corresponding sides are not proportional, these two polygons are still not similar to each other. Let's calculate the side length in units in each proportion. In each proportion, we need to find the missing length. So AB is the missing length here. So I know AB to 16 is equal to 6 to 4. If I want to find AB in a proportion, the best way is I will use cross multiply to solve the missing value. 4 times AB equals 6 times 16. 4 times AB equals 96. Then I use the skill that I learned from solving equations. I divide both sides by 4. Then we can find that the length of AB is 24 units. Let's look at the second proportion. Even the missing value appears in the denominator. If I use the cross multiply, I still can find this missing value very easily. It's 7.5 times A equals 12.5 times 1.5. 7.5A equals 12.5 times 1.5, which is 18.75. Divide both sides by 7.5. I can find the A value is 2.5. Let's find the missing length, OP, in this proportion. Cross multiply 1.3 OP equals 6 times 1.8. 6 times 1.8 is 10.8 equals 1.3 OP. Divide both sides by 1.3. OP equals 8.377. Keep going forever. So you can round this decimal to 2 decimal places, which is around 8.31. If we know how to find the missing length in a proportion, we will use this concept to solve example 3. Solving problems using the properties of similar polygons. So right now, there are two octagonal garden plots, and they are similar octagons. Let's calculate the length of HG. Calculate the length of NP. So NP is here. These two sides need to be determined. So let's look at how can we find the first missing side. To calculate HG, let's find the corresponding length in these two similar polygons. I can find AB corresponds IJ, EF corresponds MM, BC corresponds JK, ED corresponds ML, CD corresponds KL, AH corresponds IQ, FG corresponds NP. Of course, the last one is HG corresponds QP. So let's find the corresponding length. So we will have two ratios. They are proportional. HG to QP equals AB to IJ. Both of these two are corresponding sides, and both of these two side lengths are given. So I use this piece of information. I can set up the proportion. HG over 32.4 equals 5.4 over 8.1. Based on this proportion, if I want to find HG, I can cross multiply. HG times 8.1 equals 5.4 times 32.4. 5.4 times 32.4 equals 174.96 equals 8.1 HG. Let's divide both sides by 8.1. So HG equals 21.6 meters. So the first missing side is HG, and we find HG is 21.6 meters. Okay, let's use the same method to find the missing length of side NP. NP corresponds FG. So NP to FG equals IJ to AB. Of course, you guys also can use FG to NP equals AP equals AB to IJ to find the missing value, NP. So let's plug all the numbers in. So NP over FG is 27.0 meters. IJ is 8.1 meters. AB is 5.4 meters. I will use cross multiply. 5.4 times NP equals 8.1 times 27.0. 8.1 times 27.0 is 218.7 equals 5.4 NP. I will divide both sides by 5.4. So the NP value is 40.5 meters. So using another pair of corresponding sides, I can find NP is 40.5 meters. So right now, let's look at the last example, example 4. These two polygons are similar. Find the missing angles and the length. Since these two polygons are similar, we can realize that the corresponding angles must be equal in these two polygons, and their corresponding sides must be proportional as well. And then let's look at the orientation of these two similar polygons. We can realize angle A must be equal to angle E. Angle A is a 90-degree angle. This square symbol represents this angle is a right angle. So angle E is also 90 degrees. And these two angles are corresponding angles. They are equal. And angle B is equal to angle F because these two are corresponding angles. So angle B is 60 degrees as well. Angle G corresponds to angle C. So angle C is also 120 degrees. Angle H corresponds to angle D. So this one is a right angle. So angle D is a right angle. So angle H is also 90 degrees. And these two are the same. So right now we need to look for the missing length, X, Y, Z. How can we find X? So we will see X is side AB. This side corresponds EF. So AB corresponds EF. I put these two corresponding sides in one ratio. And this ratio should be equal to CD and GH because these two yellow line segments are corresponding sides. So CD over GH. Right now, let's plug all the numbers in. AB is X, EF is 40, CD is 4, GH is 3. I use cross multiply. I will find 3x equals 4 times 40. 4 times 40 is 160. Then I divide both sides by 3. So x equals 160 divided by 3. But of course, you also can represent this answer in a decimal. So 160 divided by 3 is around 53.3333. Okay. So let's find the y length. So y is BC. BC corresponds FG. Since these two polygons are similar to each other, this ratio must be equal to CD over GH. Let's substitute all the given lengths into this proportion. BC is y, FG is 32, CD is 4, GH is 3. Cross multiply. 3 times y equals 4 times 32. This one is 128. Divide both sides by 3. So the y value is 128 over 3. Or you can change this one to a decimal. The decimal is 42.6666 forever. So y side is 42.6666 units long. So let's look at the last missing side, which is z. So z is EH. This side corresponds AD. So I will write EH Usually, I like to put the missing value in the numerator of the first proportion. So EH over AD equals GH over CD. Right now, let's plug all the given values in. So EH is Z, AD is 7, equals GH is 3, CD is 4. Cross multiply for Z equals 3 times 7, which is 21. So Z equals 21 over 4. If you change this one to a decimal, it's 5.25. So Z is 5.25 units long.